In this question, we have to find voltage across this high impedance voltmeter. If you look at this bridge is nothing but a wheatstone bridge. Okay. And this product of opposite impedances are not equal. So bridge is not balanced one. Okay. If this bridge is not balanced one, definitely voltmeter is not equal to 0. Option A is wrong. Okay. Now we have to find the voltage across this voltmeter, just like a Thevenin circuit. Okay. Now we have to find voltage across this voltmeter, treat it as load terminals, and make it open. Okay. Now this is 10 ohms, 20 ohms, 10 ohms and 20 ohms. Mark these load terminals as A and B. Okay. Supply voltage is 10 volts. Okay, current flowing, let us take it as I. Okay, now what is current I here? Current I is equal to, okay, 10 by, this is 10 by 30 parallel to 30 ohms. Okay, 30 parallel to 30 ohms, so this is 10 by 15, which is equal to 2 by 3 amperes. Okay, 2 by 3 amperes. Okay, now if you see, mark the drop terminals of the current. Here current drop terminals are plus and minus. So this is plus and minus. Similarly, you have this is across 10 ohms is plus and minus, and this across 20 ohms is plus and minus. Okay, now VAB is equal to VTH. Okay, let us take A is at higher potential, B is at lower potential. Now write KVL in this loop. Okay, if you write KVL in this loop, V 10 ohms minus V 20 ohms is equal to VTH. Now what is VTH here? V 10 ohms. Current flowing through this 10 ohms is 1 by, okay, since this is 2 by 3 amperes. Okay, this is 2 by 3 amperes. Current flowing in this one is 1 by 3 and in this one is 1 by 3 amperes. Okay, now what is voltage across this 10 ohms? Voltage across this 10 ohms is 10 into 1 by 3 minus voltage across 20 ohms is 20 into 1 by 3. So this is minus 10 by 3 minus 3.33 volts. Option C is correct.
Question is, a 4-bit serial in parallel outshift resistor is used with a feedback as shown in figure. The shifting sequence is QA, QB, QC, QD. If the output is 0, 0, 0, 0 initially, then the output repeats after how many number of clock cycles? Here QA, QB, QC, QD. Initially it is 0, 0, 0, 0. If I am applying a first clock pulse, here QA and QD, after applying these two inputs to the XNOR input, then after it is feeding back to the serial input. Means QA, if both are equal, then only QA equals to 1. Again it is shifted to 0, 0, 0. At the time of second clock pulse, QB and again 1, 1, 0, 0. Third clock pulse, zero, 1, 1, 0. Again 0, 0, 1, 1. Fifth clock pulse, 0, 0, 0, 1. Sixth clock pulse, 0, 0, 0, 0. See, the initial sequence is 0, 0, 0, 0, and after the sixth clock pulse also the sequence is 0, 0. Again means again the same sequence is going to be repeated. So hence the answer is 6 clock cycles, which is option B is correct.
whose differential equation is given as dy by dx is equals to minus 2x y square, and also y of 0.2 is given as 0.96. If y of 0.1 is computed second order Runge-Kutta method, then its value is, we have to find the value of y of 0.1 of second order Runge-Kutta method. Now, it's a straightforward question, just we need to substitute the values and get the answer. Here, h is given as minus of 0.1, and let us consider the function as minus 2x y square. Now we know the formula, y1 of e is nothing but y0 plus h into the given function at y0 at naught. Now, if we substitute the values, it will be nothing but 0.996864, and also y1 of e, that is, let us take this e as 1 now, that is nothing but y1 of 1 will be nothing but y0 plus h by 2 into f of x0 comma y0 plus at 1 plus f of x1 comma y1 of e. Now if we substitute the values and if we simplify, the answer will be 0.9884, which is nothing but option C.
Assume simplified H-parameter model for the transistor circuit shown in below. HFE equals to 100, HIE equals to 900 ohms, RS equals to 0. The small signal voltage gain is given by. We know for common emitter with RA, the voltage gain is defined as for the general current gain multiplied with load resistance by input resistance. Here the current gain AI equals to minus HFE, which is equals to minus 100. Here load impedance equals to, that is 2.2 kilo ohms. Here input resistance for the common emitter with RA equals to HIE plus 1 plus HFE. RE equals to, after substituting the given values, we get 11K as the input resistance. So if we substitute the values in the equation 1, we will get AV as minus 20, which is option B is correct.